Good morning, friends. Today we are going to discuss a topic about interference. Uh, what is interference? When two gears are in mesh, it is possible that an involute portion of one will contact an non-involute portion of the other gear. This phenomenon is known as interference and occurs when the number of teeth on the smaller of the two meshing gear is less than a required minimum. Interference: when two meshing gears are rotate to each other, then uh, teeth of the one gear will be in contact with the teeth of the other gear, and there will be a slip will happen. Slip, which is a frictional contact between two teeth, and due to this slipping, the speed of the gear will be reduced. So that effect is known as interference. Okay, we are moving to next slide. See, the teeth of the one gear is contact with the teeth of the other gear. You can see that, see it in that picture. Pinion, after pinion, you can see that the interference is happening in here. So this is interference basically. So we are moving to next slide. Interference of spur gear. Interference is happening on all the type of the gear: spur gear, helical gear, and herringbone gear. And most of the gear there will be interference. And by reducing, there are so many ways to reduce these types of interference by following most of the steps. First of all, we are going to see about interference of spur gear. The formula to calculate the interference of spur gear is Np is equal to 2k by 3 sine square pi. Here pi is the pressure angle, and 1 plus root of 1 plus 3 sine square pi. This is a standard formula used to find out the interference for spur gear. Okay. Methods to avoid interference. Okay, we are going to now see about the methods to reduce interference. Uses of large pressure angle. Pressure angle. First of all, pressure angle is a angle made between the tangent pressure line of contact, the angle between the line of contact and line tangent to the pitch circle, and there will be a angle, that angle is known as pressure angle. So by increasing the pressure angle, we can reduce the interference among the two meshing gear, and then the increasing the number of teeth. So by increasing the number of teeth, we can also reduce the interference. If two meshing gear has small number of teeth, then the interference will occur. The chances of interference will be more. So the way to reduce interference is by increasing the number of teeth in both the meshing gear, and then increasing slightly the center distance. So by increasing the center distance between the two meshing gear, we can reduce the interference. And then tooth profile modification. Gear with the non-profile teeth can also eliminate interference. And then that is not understanding, that is undercutting. Sorry, it is my mistake. Undercutting is the process to cutting the tooth where the interferences occur. By cutting the tooth of interfere between the two meshing gear, we can reduce the interference. And then these are some of the standard values. System of gear teeth. This is some of the standard values. Minimum number of teeth on the pinion. Pinion is the small number of small size gear. Okay. And then we are going to see about problems. Okay. A pinion of 20 involute teeth. The number of teeth was given, and 125 mm pitch circle diameter. Diameter of the pitch circle is also given. The addendum of both pinion and rake is 6.25 mm. What is the least pressure angle which can be used to avoid interference? So yeah, asking what is the pressure angle to reduce the avoid interference. How? Okay, we are going to find out what is the pressure angle, and then find the length of the arc of contact and the minimum number of teeth in contact at a time. And we are going to find out the arc of contact and number of teeth in contact at a time. Okay, first of all, we are going to use this formula. Sine square pi is equal to LH by R. LH is equal to least pressure. LHS is the addendum of both pinion and rake, which is the given value. By substituting these values, we will get sine square is equal to 0.1 and pi is equal to 18.435 degree. So we have find out the pressure angle to avoid interference, and then we are going to find out the length of the arc of contact. We know the formula KL is equal to root of OK. By applying this formula, we will find out the length of arc of contact by substituting the given values. Substitute the given values, we will find out the length of arc of contact, and then we are going to find out the minimum number of teeth. P is equal to pi d by t. Circular pitch formula, we know the formula for circular pitch, and by substituting these values in this formula, we will find out the minimum number of teeth. And the number of pairs of teeth in contact length is equal to length of the arc of contact by circular pitch, and then we will find out the minimum number of teeth in contact is equal to 2. Okay, we move to next sum. A pair of involutes per gear with a 16-degree pressure angle and pitch of module 6 mm is in mesh. The number of teeth on pinion is 16 and its rotational speed is 240 rpm. When the gear ratio is 1.75, find in order that the interference is just avoided. First, the addenda on pinion and gear wheel, and second, the length of the path of contact. Third, the maximum velocity of sliding of teeth on either side of the pitch point. Okay, we are going to find out first of all addenda on pinion and gear wheel. We know the standard formula is equal to addendum on pinion is equal to mt by 2 root of 1 plus capital T number of teeth on gear by number of teeth on pinion by divided by capital T by small t plus 2 sine square pi minus 1 is equal to, and then we substituting the given values in this formula to find out the addenda on pinion and gear wheel. Okay, and then we are going to find out the length of path of contact. We know that the pitch circle radius of wheel is equal to R is equal to m into t by 2. Here m is the module and t is the number of teeth on the gear. Okay, and then we are substitute the given values in this formula to find out the answer. Okay friends, and then we are moving to finally we are going to find out the maximum velocity of sliding of teeth on either side of the pitch point. Omega is equal to angular speed of a gear wheel, and omega 1 by omega 2. Omega 1 is the angular speed of gear and omega 2 is the angular speed of pinion, is equal to capital D by small t is equal to 1.75. You know the value of omega 1, so by knowing this formula we will able to find out the angular speed of pinion, and then the final answer is force 471 mm per second. Thank you. That's all about interference.